Hey there, Marcus Hutzel here, and in this video, I'm going to be busting an audio myth, and I'm going to show you this with actual tests with all of this equipment. Because as someone who's been in live production for a long time, as an audio engineer myself, as someone who has operated audio, and also as a project manager in charge of hiring other people to run audio, I've come across a wide diversity of people and skill levels, and I've come across a lot of people spouting misconceptions about what they think their audio gear does, how it performs, and what they think certain settings do. And honestly, just not understanding the effects that their choices have on their audio. But one of the biggest audio myths or misconceptions that I hear almost on a daily basis is this one. Gaining the mic low means the mic hears less. It pulls in the bubble of sound that the mic captures. And this is just scientifically wrong, and it's a bit absurd. It's just not true at all. They think that by keeping the mic preamp here on this console really low, that it will somehow change what the microphone hears. Microphones don't work like that. Microphones do not rely on electrical amplification downstream to operate. They just do not require that input gain so that they can hear anything at all. Microphones work by air pressure hitting their diaphragms. Any and everything on Earth that can move air molecules, like my voice, a rocket ship, a bird singing, a basketball bouncing, all of that sound that we hear is simply some force pushing air molecules at a certain frequency or frequencies and at certain pressures, which equates to sound being louder or softer or moving more or less air. And all of those sound sources move through the air molecules here on Earth, and that air pressure arrives at our eardrums or our microphones just the same. Our ears and our microphones simply sit where we place them and get hit by sound pressure at all times. The only thing we can do to change what they hear is either orient them in a different direction or cover them up. Remember that for dynamic microphones, the air moves a diaphragm that pushes on a magnet which sits inside a coil of wire, and the movement of the magnet by the diaphragm produces a small electrical voltage that gets sent down the cable. Condenser mics don't have the same magnet or same coil of wire, but their electrical signals that get sent down the cable are still generated the same way by air pressure hitting the front of the mic. Microphones, at least dynamic mics, work even when they're not plugged in. This SM58 is working right now. The air pressure from my voice is literally moving the diaphragm and the coil of wire inside this mic right now. And there's a small electrical voltage coming out of the pins right there. It's working literally without being plugged into anything. Our preamps and other gear simply receive whatever is coming down the cable and can do with that signal whatever it or we want to do, like amplify or gain it up or not. The receiving device, in this case, this mic preamp on this console, has no effect on what this microphone hears or not. Gaining up an incoming signal to our audio consoles can't change the air pressure hitting a microphone, especially when that microphone is 100 feet away on a stage. How could it? How can a knob on this audio console have any effect on the sound pressure coming from my voice? And if you think that's wrong, then think about this. Wireless microphones. With a wireless microphone, there is no direct connection between the microphone diaphragm of the mic to your audio console's mic preamp. The mic capsule is in the hand of whomever is speaking or singing, and that signal gets generated at the mic by the person's voice hitting that diaphragm, and that gets transmitted wirelessly through the air over to the mic receiver, and the receiver is then plugged into the audio console and therefore the preamp. So how would it even be possible for the knob on this console to have any effect on a microphone diaphragm that is not even physically connected to it? Short answer, it can't. The mic will get hit by sound waves wherever the mic is located, and we can do with that signal what we want. And I'm going to prove that right now with some tests, and I'll show you that different gain settings on preamps have no effect on what this microphone hears. So let's get into it. All right, so quick change of view so you can see everything a little bit better. All right, so how exactly are we going to test whether gaining low or gaining high affects what a microphone hears or not? Well, if you look at the side shot here, I've got an SM58, a Shure SM58, pointed right at this speaker, this Atom T5V speaker. And directly connected to that speaker, I've got my iPad. So this iPad basically has a 3.5 millimeter cable going to an XLR adapter that goes right to that speaker so that I can play audio files out of the iPad and they come directly out of the speaker instead of going through any other mixer. I'll play a sine tone first to set a level, and then also on the iPad I have a pre-recorded file of my voice, and what that allows me to do is it allows me to have a consistent SPL level that microphone always hears. So when I get to playing the files, I won't actually change the volume level, so that every time I play the pre-recorded file and the tone from this iPad, it comes out of that speaker at the exact same SPL level. The microphone doesn't move, the speaker volume doesn't change, the iPad volume doesn't change. So I'm using that as my talent, as the sound source that we want to capture, because if I do it with my voice every time, I could have inconsistencies in the way I speak. This allows me to have that SPL level as a constant going into that microphone. That microphone is then plugged into this Behringer 1204 USB mixer, and I'm USBing this directly into my laptop so we can bypass any sort of external recording devices. This is just going directly into Adobe Audition so that we can record what this mixer is picking up via the gain and everything from the mic going into Audition. We'll be able to make those measurements there. So that's great, but how does that really determine what this mic hears as far as like this myth of the bubble of sound? Remember, my problem with this myth is that people claim that if they keep the gain pots low, that this mic will not pick up as much ambient sound outside of its, purview. Well, to test that, I have another speaker way over there. It's right there. I'll try to put a little B-roll close-up of it. What that speaker is doing, well, I've got this other laptop hooked up directly to that speaker. And when I hit spacebar on this laptop, it plays a sine tone out of that speaker. And what that allows me to do is that allows me to have a consistent noise in the distance that this mic can or cannot hear more or less depending on our gain settings. And I'm not changing the volume output of this laptop feeding that speaker, so every single time I hit spacebar, we'll get the same volume level or the same SPL level out of that speaker no matter what we're doing over here. And that speaker is more or less pointed directly at the microphone, and it's even pointed at the back end of its cardioid pattern a little bit, so it's really kind of in the rejection zone of the SM58 microphone. So we'll play two main files out of here, a 200 hertz tone, and then my pre-recorded file. We'll gain structure, get a level into Audition based on that, and then I will pause all of that while still recording, and then I'll hit play on the 1K or 1000 hertz tone coming out of that speaker, all in the same recording file based on whatever gain structure we're using for that recording, and then we'll be able to measure in the recorded file if this microphone picked up that ambient sound more or less depending on where my gain is sitting. All right, so I'm going to put headphones on for this because it's going to get a little loud in here. And you can see here in Adobe Audition, I've got two tracks ready to go. I've got a gain low track where we're going to set low gain on the console, and then I've got a gain high track where we're going to set our gain high on the console, record both of those. So when I start playing my initial 200 hertz sine wave out of the iPad, I'm going to keep the gain pot here on input 1 as low as I can while having the faders as near unity as possible. But again, with low gain, I'm going to have to use the faders to push a little more level into Audition just to hit where I want. And I'm going to aim for -12 as a baseline for input on both gain structures. So let's just play our sine tone and we'll get started. This is a quick recording of me speaking into my Rode Video Mic NTG so that we can play this file back and have a consistent waveform every single time. And that's it. Now we'll regain structure, record the same exact files, and then we'll hop into Audition and test those results. All right, so we'll start fresh. And this time I will get the gain up as high as I can without clipping out the preamp on the console. We'll feed in the same level into Audition, looking for that -12 on our initial sine tone. We'll hit record and record everything. So here we go. This is a quick recording of me speaking into my Rode Video Mic NTG so that we can play this file back and have a consistent waveform every single time. All right, let's look at those results. All right, so you can see here, I've got Adobe Audition open, and what we're going to do here to, check how much this mic heard that distant sound. Well, the first thing we want to do is just double check that our final end product, our final audio input into Audition was the same regardless of the gain settings. And if you remember when I was gaining low here on the preamp, I had to push a little more fader level to get that -12 dB in, and we can see that level here as we play it. We've got that -12 dB in on the low gain. And then when I was gaining up high, I just pulled the faders back a bit, but we can see here when I play here on the high gain track that we still have -12. So our final output of the console, and therefore the input into Adobe Audition, was the same. Therefore, when we measure the end of these recorded files, we'll know that our overall recorded level was the same for both these files. So what we'll do here is on the low gain, where I had the gain set low here on the console, we can see my input level. We'll double click into the file, and then I will find over here at the end, I'll have to listen very carefully to find exactly where that tone started, because I don't want to measure silence. I want to measure the 1K tone coming out of that speaker. And we'll find that tone real quick. Okay, it starts there. I just want to make sure that the area that I'm going to scan here at the end completely contains that 1K tone. So let's just double check. Okay, it's at the beginning. Great, now we'll just hit scan selection and we can see the overall RMS value of that section. And we come up with -61.76. Write that number down because -61.76 in this initial scan is the overall volume level that this microphone heard when we were playing that distant tone with the low gain. So now all we have to do is go back over here and double click on our second file where we had stronger input gain on the console. We'll find where that tone starts playing. Okay, there it is. And we'll make sure we have the entirety of the tone encompassed in our scan selection. Okay, we do. So we'll hit scan selection. And now we have -61.44. So what does that mean? What these two numbers mean, -61.76 and -61.44, is that when we measured what this microphone heard from that distant speaker, they both measure the overall volume of that distant speaker at -61 dB. There's a slight variance, 61.76 minus 61.44. All right, so that's a 0.32 dB difference in what this microphone heard on that one test when it was gain low versus gain high. And this isn't just a measurement of system noise. This is the audible audio that the SM58 picked up. And if we go to our files here in Adobe Audition and we cut out a small portion of each of the recorded files, I'll cut out a portion of the low gain where I know that the 1K tone was playing, and I'll cut out a similar portion of the high gain recorded file where I know that the 1K tone was playing, and I bring them down to new track and let's put them side by side. And now because these files are fairly low as far as dB is concerned, they're at -61 dB FS. we will take and I'll add, in this case, let's add 20 dB to each one so that they're actually more loud to you here on the audio recording. But since I'm adding the same amount of gain here in addition to each one, then they'll be equal in terms of how much I've boosted them. So now I'll just play them back to back. And you can hear with your ears and see on the meters that, again, that distant tone was picked up more or less equally by this SM58 microphone, no matter where my gain was located on my console. So basically, this microphone heard that distant tone at the same level, basically negative 61 dB, no matter whether it was gained low on the console or high on the console. It heard it at the same level. There's a slight variance, but remember that that's sound pushing air molecules from there to here. So there could have been a slight variance in the temperature of the room, how much heat I'm putting off because I'm actually slightly in the path, or at least my breath is. Maybe my breath was causing the waves to make a little bit of difference. But all that is negligible for a 0.32 dB difference. And I actually did this test 3 more times, and I reset the gain every single time and did the negative 12 initial level into Audition and played the file, played the tone, and we'll look at those measurements now. All right, so here we can see my other 3 tests. These 3 green ones are where I had low gain on the console, and these 3 other purple tests are where I had high gain on the console. And if we measure the same thing by double-clicking into the file, finding where the tone's playing, and measuring that on all of these other files and comparing them, what we come up with is very simple. It's exactly what I expected. Every single time, basically, this microphone heard that distant tone or that distant sound the same every single time. So if we look at these results with the second measurement, with low gain, I measured the distant tone at negative 60.25, regaining to high, I measured the distant tone at negative 61.44, and in this case, the higher input gain, the distant tone was actually quieter, so it favored the higher input gain on that particular measurement. But again, we're within like a dB of each other. Measurement 3 is basically the same thing, negative 60.63 when I was gained low, and when I regained high, the microphone heard that distant tone at negative 60.97. And again, that's only about a 0.34 difference. And on the 4th and last test, I measured with low gain, I measured the distant tone at negative 60.74, and regaining high, I measured the distant tone at negative 60.3. But you can see from these tests that we're still within, a dB or half a dB or even 0.3 of a dB, and it doesn't favor low gain or high gain every time. The result of scanning these selections in Audition just measures what it hears, and so there's slight variances, but overall, this microphone heard that distant tone at the same level every single time I regained structured. Didn't matter whether the gain was low or the gain was high. This microphone heard that at the same level every single time, which just proves that your gain on your console has no effect on what this microphone hears. It can't. This is just gaining up the signal that it gets from the microphone, and we can do with that what we want. All right, so to summarize, gaining low-ish or gaining high up to where the preamp really should be has no effect on what this microphone hears in the distance. It has no effect on its bubble of sound because that's just not how microphones work. Microphones work by air pressure hitting their diaphragms. Remember, microphones are about physics and acoustics. Microphones really are not about electronics. They react to our environment with air pressure, and that's just how they work. Consoles and input gains on mic preamps can't affect what they hear. So I really hope you've learned something from this video. Please tell your audio engineer friends. I really am on a mission to stop these audio myths. I want us all to pull back, remember how equipment works, learn how it works, and then, have all the information available to you to be able to pass on to the next person. Because if you're passing on bad information that you just heard from someone, that's hurting the next engineer in line. They're going to keep spouting these myths when I've plainly shown it's just not the case in this case. So happy engineering. Go out there and do some good work. Let me know if you have any questions or comments. Hit those like and subscribe buttons. It really, really helps out my channel. And I really like talking about this stuff, as you might have been able to tell since I won't shut up. So now I'll shut up. I'll see you in the next one. Later.